We're going to do the second half of 6.7 today, which is called the quadratic formula. And before we actually get into this lesson here, we're actually going to first prove the quadratic formula. So this is actually on the back page of the notes. It's like kind of like a separate page off on its own. So before we actually start it, we're going to prove like kind of where it comes from. And then we'll be able to use this formula over and over in the rest of the lesson. So let's look at number 1 here, which says, prove the following. If ax squared plus bx plus c equals 0, then x equals what? So this is where we're going to fill in the blank here. But we don't know what this is yet. Our goal is to take this original equation with a, b, and c in it, right? We see that's equal to 0, so this would be kind of like we're solving for the roots. Like we're trying to see where it crosses the x-axis type of thing. We've done this before where we had to like factor this side and see what makes it 0. We're going to do this now, but do some extra work, some stuff that we've done before, like completing the square and things like that. And we're going to solve this equation here for x. So the whole goal is to eventually get x equals something. And then we'll write it in the box. So what I'm going to do first is I'm going to just copy it down. Ax squared plus bx plus c. Right, this is starting to look like your standard form, right? And then what we're going to do first is kind of on the start of making this into vertex form. That's kind of our goal here. I'm going to subtract c on both sides. Most of the steps that I do, you should be able to follow, even though it might get a little crazy. And then we have ax squared plus bx equals 0 minus c is negative c. Okay, I'm going to do something a little different. So at one point, we looked at the a value that was out front here, right? And we factored that out. Now, we had to do that before because there was a y over here, but we don't have a y on this side. We are going to mess with this a, but we're going to get rid of it by dividing the entire equation by a. And so what I mean by that is we're going to divide everything on this side by a and everything on this side by a. So if you remember, a, b, and c are just going to be numbers, right? So we're going to divide both sides by a. And what happens here is we have the a goes to this one, and the a goes to this one. So we get x squared, a divided by a, but the other one has b over a x equals, and then same thing over here, we have it dividing by a, but you can't do anything with that. So if you remember, we've actually seen this before, this b over a thing. We're going to now do the completing the square thing where we put blank spots in here. So I'm just going to put a blank on both sides here. But we have to go off to the side, see if I have enough room. Maybe. It's going to take up quite a bit of room. I'm going to go off the side. I'm going to take this piece, right, and go off to the side. We're going to do b over a divided by 2. I'm going to do this again. I think I've already went through how to do this, so I'm going to go a little bit faster on how to deal with this b over a divided by 2. Remember, this is the keep, change, flip thing, so I'm going to do b over a times 1 over 2 squared. And that's the same thing as saying b over 2a squared, which would be b squared over 4a squared. That stuff we have already actually done before in a previous problem. It was also in a different set of notes, so this should be nothing new here. So I'm going to add that into both sides. B squared over 4a squared. And I'll just use that line as my fraction. B squared over 4a squared. Okay, I think we're about ready now. Now this side on the left, we're actually going to factor this. Remember, we don't actually have to factor it. We just have to figure out, well, what did we get when we divided by 2? And that's over here somewhere. Dividing by 2 is the same thing as multiplying by 1 over 2. So right here, I would highlight this. I wonder if it's highlighter. This is what ends up being down here, if you remember. So let's write that out. We have x plus b over 2a, and that's being squared, equals, now on this side on the right here, we have to get these two fractions to be the same. And so there was a lesson where we learned how do we get them to be the same. Well, we need to have the same denominator, and so this one here is missing a 4, so we're going to divide, or we're going to have multiply by 4 over 4. It's also missing an a. It has an a already, but it needs an a squared, so we're also going to tack on an a. All right, so this side over here we have b squared over 4a squared minus c times 4a on top here would be 4, I'm just going to put it together, 4a times c all over, remember if we put these two together here, we're going to get 4a squared again, which is what we want. And so now we can actually make it one fraction. So I guess I'll spend time doing that as a step. So we have b squared minus 4ac all over 4a squared. And I'll bring this side down. We're almost there. We're getting close. So our goal is to get x by itself. So we have everything over here, no x's. This side we do have an x. We're going to get rid of this 2 that's up here. And the way we get rid of a squared is by doing the square root. And now we have to do that to this big fraction. So I'm going to draw a big one over here. So we have to square root the top and the bottom of this fraction. And if you remember, when you square root, this is usually when you separate into 2 different answers where you have one with positive, one with negative. I'm going to show you a different way to write this. We're just going to write this as a plus minus. So I'll show you that in a second here. So this gets rid of the squared. We don't have this anymore. Should go back to my pen here. We don't have this anymore. We just have x plus b over 2a equals, when we square root this, like I said, we're going to get a positive and a negative. So I'm going to put plus minus, the square root. The top we can't really do anything with. We'll keep this b squared minus 4ac. The bottom we can square root. So kind of off to the side, I'm going to square root 4a squared. And the square root of 4 is 2. The square root of a squared, if you believe it or not, you have your squared crosses out with your 2 there. This becomes a. And we're almost done here. We have to bring over this b over 2a by subtracting it. Minus b over 2a. So that will cancel those out, and we will get our final answer, x equals negative b over 2a. I don't know if you noticed, but they already have the same denominator. So I'm just going to make this a big fraction here. And then we have plus or minus the square root, b squared minus 4ac. So this is actually the formula for the quadratic equations to solve for x. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we need to put in the box. Negative b plus or minus the square root b squared minus 4ac all over 2a. So this will be the formula we're going to use. Remember what a, b, and c stand for. It's just the numbers that are right out front in your beginning equation here. As long as you have this set up with it equal to 0, because we had to start with, we went through the entire proof of getting this answer here. So now we have it. And so now we can use it. So let's go to our lesson now. Quadratic formula. How do you find the roots of a quadratic if you cannot factor? So this is really where it comes into play. We talked about factoring for so long, but what if you can't factor? Then we can use this. So if we have ax squared plus bx plus c equals 0, and the only restriction on this is that a cannot be equal to 0. If we had a equals 0, then we don't have any x squared value at all, and that's an issue down here. As you notice, when you have it over 2a, can't have 0 on the bottom because you can't divide by 0, so that's your restriction up here. So here it is. It's the same thing as we had on the previous paper. So we're going to practice this. First example, we're going to look back at the warm-up and use the quadratic formula to find the zeros. So this is actually the warm-up problem. So I just kind of copied it off of the warm-up here. Here it is. The only thing I did is I put a 0 in for the y. I think it did. Oh, we're going to do that. We'll plug a 0 in for y, and then we can label A, B, C, and then practice using this. So that's what I'll do. I'll make this 0 equals x squared plus 8x plus 13. And let's label A, B, and C. The a value will be 1, because it's the one out front of x squared. B is 8, C is 13. Now we just got to use this up here. So I'm going to write this out as x equals. Our whole goal is just to really mess with this right-hand side and do this whole entire thing. Negative b, so we have negative 8 plus or minus the square root. B squared is 8 squared minus 4, that's in our formula, times a, which is times 1, times c, which is 13, all divided by 2 times a, which is 2 times 1. Once we figure out what this is, then we can figure out what the zeros are. That's our whole goal, to find the zeros. What I would highly suggest is that you would do the inside of the square root first. So that's kind of key here. We want to do this part first. Get rid of this nasty square root symbol, and then we can keep going with it. So let's go ahead and figure out what's inside the square root. We have 8 squared, which is 64, minus 4 times 1 times 13. So you basically figure out what 4 times 13 is, and that is 52. I'm trying to look at something here. So we have x equals negative 8 plus or minus the square root of 12. All over 2. This is going to be ugly. At this point, we have to do the square root of 12, which is not going to be a very nice number. So we're going to get about 3.46. I'll round to 3.5, round it up. I'll do one more line down here. So x equals negative 8 plus or minus 3.5 all over 2. At this point, we need to split it into 2 different equations. So we'll split it. Also, okay. So we have x equals negative 8 plus 3.5 all over 2. Or our other option is to have negative 8 minus 3.5 over 2. So then all you have to do is finish the numerator for both of them and then divide by 2. So I'll do that all in one step. We have negative 8 plus 3.5, which is negative 4.5, divided by 2, which is negative 2.25. That's one of your answers. That's pretty ugly here. And then the other one, we have negative 8 minus 3.5, which is negative 11.5. We divide that by 2, negative 5.75. So there's your two answers. So we would say x equals this or x equals this one. Just be careful whenever you split this up. You have to have a plus version and a minus version, which gets split up right in the middle here. All right, how about part A? Factor the same quadratic to show that you get the same roots. All right, so let's go back to our original quadratic. We have x squared plus, what was it, 8x plus 13 from up here? Yeah. So if we try to factor this, we have 13 Trying to multiply to 13, and we're trying to add to 8. Well, the problem here is we have 13 times 1, and that's the only thing you can use. So there's no way to add them together to get 8. It's not going to work. So again, if this happens, we cannot factor. Let's fill in the blanks. So when do we use the quadratic formula? Specifically this time right here, because we're not able to factor. So there's no way to figure out, what parentheses says to put here, because it won't work. As you can tell from before, these answers here are decimals, and we're not going to get decimals here. Sometimes you could whenever you do factoring, but this factoring doesn't work out. You try to use shortcut method, it doesn't work. I think I'm going to try like a couple more with you, and then we'll do a word problem and then be done. Example 2, we're going to put the following polynomials into standard form if we have to. Look at part B. It's not in standard form, and we don't have one side equal to 0. Then find the roots using the quadratic formula. All right, so we'll do part A. So 2x squared, we have a is 2, b is -3, c is 1. You just have to memorize the quadratic formula. It's negative b, so it's -3. That will turn to positive, plus or minus the square root. B squared is -3 squared. Make sure you put in parentheses. Minus 4 times 2, which is a, times c, which is 1. All over 2 times, a is 2. Okay. So I'm going to simplify some of this now. We have x equals 3 plus or minus. Let's see what the square root inside here is. That would be 9 minus 4 times 2, which is 8. So it's 1. The bottom is 2 times 2 or 4. Okay. X equals 3 plus or minus. The square root of 1 is 1. I don't know why I made such a big square root symbol. Over 4. Now we can split them into two answers, or one answer will be 3 plus 1 over 4, or 3 minus 1 over 4. We're still getting these two answers here. So we get 4 over 4, which is 1, or 2 over 4, which is 1/2. So those are your two answers. Okay, now with part B, we have to move over the 3. So I'm going to subtract 3. We're kind of used to doing this, getting 0 to one side. And then we're going to label A, B, C. So A is 1, B is 2, C is -3. So we're going to do negative B to plus or minus the square root, B squared, which is 2 squared, minus 4 times A, which is 1, times C. Put a little -3 in parentheses here. All over 2 times A, which is 1. All right, -2 plus or minus the square root. That would be 4 inside there, minus, -4 times -3 is positive 12. So 4 plus 12 is 16. All over 2. I'll go ahead and split this one now. We have -2 plus square root of 16 is 4 over 2, or -2 minus square root of 16 is 4 over 2. So this one would give us a 2 over 2, or 1, or -6 over 2, which is -3. And those are your two answers. I really should put little x equals in here, because those are the two roots you have. Maybe I'll do one more. See if I can do one more. Okay, how about part C? This one's in all kinds of a mess here. I'm going to add 5x. I'm specifically going to put it in the middle. So I have x squared plus 5x minus 1 equals 0. Label my ABC, A, B, C. Let's try it. X equals negative b, so -5, plus or minus the square root, b squared, which is, might as well throw it in there, 25, minus 4 times 1 times -1. There we go. Alrighty, the bottom would be 2 times a, which is 1. This one's going to be kind of ugly. The square root of, what are we doing here? 25, negative 4, and negative 1 is 4. So you're going to add them together to get 29. That's going to be kind of ugly. Square root of 29 will be a little over 5. 5.38. So I'll do 5.4 to round it up. It's all over 2. So I'll go ahead and split it now. So negative 5 plus 5. What did I say it was? 5.4. If you round it up. Over 2. Or negative 5 minus 5.4 over 2. So this would give us what? 0.4 over 2, which is 0.2. Or negative 10.4 over 2, which is negative 5.2. That looks like your two answers. It looks kind of ugly here, but sorry. There we go. Okay, we're going to skip part D, and we're also going to skip, you guys can do some of the huddle. There's 6 problems there. I'm going to skip example 3. I would like to finish up with the last word problem here. So Mr. Karagine tried throwing a football to Mr. Shalednik, and we're going to let X be the distance between both teachers, and Y is the height of the ball at that distance, and we're going to use this equation. Okay, so let's draw a little picture here. Throwing a ball. And then maybe Karagine or whoever is he's going to catch it up in the air. So, let's put his arm up here. We want him to say that the ball is going to go across, then he's going to catch it at some point. Or maybe it's like a little lower. Maybe I shouldn't do that way. Let's go down here. And he catches it, down here somewhere. All right, to the nearest foot, how far away is Mr. Shalednik from Mr. Karagine if he catches the ball at a height of 5 feet? So we know the height here is 5 feet when he catches the ball right there. We're trying to find the distance between them. And it does say X is the distance between them, so we're trying to find X, and Y is the height of the ball at that distance. So we know the height is 5. That's Y. So it says substitute Y equals 5 feet to get the equation in standard form. Then we're going to use the quadratic formula. So I'm going to throw in 5 here because that's the height of the ball. And then we're going to solve for X. So 5 equals negative X squared plus 5X plus 20. Okay, so I'm going to go ahead and subtract 5 on both sides to get this side to be 0. So I have negative X squared plus 5X plus 15. Now, normally we care about getting this negative sign and not having negative X squared. But in this case, it doesn't matter because we're not factoring it. We're just going to use that negative 1 as our A value. So once we identify A, B, and C, we should be good. So we're going to do negative B, which is negative 5, plus or minus the square root, B squared, which is 25, 5 squared, minus 4 times 1 times, A is negative 1, times C, which is 15. All over 2 times negative 1. Careful with that negative 1. It's showing up quite a bit. So it looks like we're going to have, inside here, we're going to have 60 plus 25. So that's going to be 85. So negative 5 plus or minus square root of 85. You can go ahead and multiply that out because you get a positive 60 between these three and adding 25 to it. The bottom's negative 2. I'm just going to keep going here. So we have the square root of 85. Again, not a nice number. It's about 9.2. So I'm going to do negative 5 plus or minus 9.2 over negative 2. And then here's our two answers. Let's go ahead and break it apart. Negative 5 plus 9.2 over 2, negative 2. Finish that one off. Or negative 5 minus 9.2 over negative 2. And one of these answers will make sense. The top one, that will give you a 4.2 over negative 2. Seems like that'd be negative 2.1. Not going to use that. That's a negative distance. That's probably talking about behind him. This one we get negative 14.2 over negative 2. And that will give us a positive 7.1. So it looks like we're looking about 7.1 feet away from each other. 7.1 feet. That would be the one that we would look at. That should finish up the entirety of 6.7. And using the quadratic formula, the rest you have to finish is, you don't have to do this example 3 here. This one has just a little too many decimals involved, but you should also do the warm-up plus these 6 problems. The warm-up is just changing it to vertex form and then graphing it and asking a question where it crosses the x-axis. And that's all for 6.7.